All right. Good morning once again, my beloved students. We are making progress in the course of this course. Today, we'll be looking at we'll be looking at equilibria in solution, and this is actually the okay. Sorry for the little itch. All right, so we're looking at very nice. Well, sorry for the little itches here and there once again. I mean, I could see some of you already complaining that the data is going and that you're not hearing. I hope you are hearing well now. would like to hear feedback from you before I proceed. Please, let me hear what your response is. If you're hearing, okay, I'm happy to know that you are hearing what I'm teaching. All right, like I said, I'll be looking at equilibria in solution. All right. So as I was saying, equilibria in solution is apparently the area of this course or this topic that's of relevance to our day-to-day activity, because most of the reactions studied are usually in solution. And that is why studying equilibrium in solution is very, very important. All right. So, like I said, acid and bases in many common consumer products are indispensable for both academic and industrial research. Like we all know from Arrhenius' definition of an acid, that an acid is a substance with hydrogen in its formula and dissociates in water to yield hydroxonium ion. So, that's Arrhenius' definition, that an acid is any substance, when dissolved in solution, produces hydrogen ion as the only positive ion. Similarly, according to that same definition or concept, a base is a substance with OH in its formula. And of course, when it dissociates in water, it produces hydroxide ion. And of course, we all know that when an acid and a base react, they undergo neutralization. Now, let me, at the onset, let me make us understand that it is not every acid-base reaction that we can term neutralization. Neutralization is actually a term for the reaction between a strong acid and a strong base. You will understand this concept much better as we proceed in the course of this study. Okay, so according to Arrhenius' definition, neutralization will occur when hydrogen from an acid and OH from a base form H2O. Okay, that is Arrhenius' definition of neutralization. All right, but with time you find out that it is not every acid-base reaction that we can call neutralization. All right. So here we have a list of some substances we're familiar with day to day that are acid and bases. Of course, acetic acid as a preservative in food and drinks, citric acid, for flavoring lemon juice, ascorbic acid. We are all familiar with ascorbic acid. The cold season or the harmattan season is fast approaching. You need to build your immunity, and to build your immunity, you need to take in vitamin C. Okay, either from fruits or from from nutritional supplement. Okay, we also, I know a number of you are bakers. You make cakes, you make pastries, and so I really should not be telling you much about this anyway, because it's something you are familiar with. Aluminum salt found in baking powder with sodium hydrogen carbonate. What of bases? Okay, sodium hydroxide. If you have a clogged drainage system, all you need to do is just prepare some solution of sodium hydroxide and pour in there. It will clean up all the mess and, of course, allow the flow of liquid. Ammonia, of course, also used as household cleaner. So, I mean, the lists are just there for you to have a feel of why the study of acid-base equilibria is very, very important. All right. When we talk about an acid or a base, we classify acid and bases on their strength. So we have what we call strong acid and, of course, strong bases. The strength of the acid is actually determined by the amount of hydroxonium ion or hydrogen ion produced per mole of such a substance. And of course, the same thing goes for a base. The strength of a base is a function of the amount of hydroxide ion produced when such a base is dissolved. All right. And so that means, therefore, that a factor that will determine the strength of the acid or a base would be the extent to which the acid or base dissociates into ions. Because a solution that will not dissociate appreciably will not produce enough hydroxonium or hydroxide ion to be termed as a strong acid. Okay, so because acid and bases are electrolytes, like I said, their strength has a correlation with the strength of the electrolyte. So a strong electrolyte dissociates completely, while a weak electrolyte dissociates slightly. And so therefore, a strong acid is a strong electrolyte that dissociates completely into ions in water. As you can see from the equation here, you have HA dissolving in water. HA may be a gas, for example, hydrogen chloride gas dissolving in water, hydrogen fluoride dissolving in water, or it could be liquid, oleum, H2SO4, HNO3. These are liquid. When dissolved in water, they produce hydroxonium ion and the corresponding anion. Okay, so the strength of this reaction will show the extent of this dissociation will show the strength of what is dissolving. Now, when an acid is a strong acid or a strong base, we represent that by a single arrow that is pointing towards the product. We are assuming there's a complete dissociation of the acid on the reactant side to give us the hydroxonium ion on the product side. Okay, so in dilute solution of a strong acid, this is what we have. Okay, I mean, just what I wrote previously. So in this case, if it is complete dissociation or ionization, by the time the ionization has completed, you will not see any HA molecules anymore. In one word, all the HA have been transformed completely to hydroxonium ion, such that we can say that whatever concentration of HA, whatever concentration we have of HA initially, whatever concentration of the acid that we have initially will be exactly equals to or approximately equals to the amount of H plus or H3O plus, which of course will be also equals to the amount of the corresponding anion that is formed. Okay, in one word, all these have been transformed to this and this equal concentration according to the stoichiometry of the reaction. Okay, so the value of the equilibrium constant, of course, is going to be large in the sense that since this will be very, very negligibly small after the ionization, you have more of numerator and there is no denominator. So we are saying this is very, very, significantly far greater than 1. Okay. Example of such acid, of course, we include, like I mentioned, nitric acid, H2SO4, hypochlorite acid, and what is here? Come in, please. Okay, I'm sure you can see it. Something is blocking what I wrote there. That's why I couldn't see it. But don't worry. All right, I can see it now. Okay. And of course, HClO4. Okay. Now, for weak acid, however, they do not dissociate appreciably, such that after the dissociation had come to an end, you have hydroxonium ion and the corresponding anion. You still have a great majority of your undissociated starting material in solution. So in one word, an equilibrium is established between the undissociated acid and, of course, the hydroxonium ion and the corresponding anion that is formed. So in that case, we are saying that the amount of hydroxonium ion formed, or hydrated hydrogen ion, because hydroxonium ion simply stands for hydrated hydrogen ion, is far, far less than the initial concentration of the acid given, okay, such that we can say, to a very, very close approximation in most cases, that the amount of acid left at equilibrium is very, very close to what you started with. In one word, it does not dissociate appreciably. So if you write the equilibrium constants for that, which of course I can write here, for the weak acid, so we call that, let's call that Ka, that will be equals to H3O plus A minus over HA. Since HA is far, far greater than H3O plus and A minus, it means that we have more of the denominator than we have the numerator. And consequently, since the numerator is very small, the value of Ka, or the dissociation, the equilibrium constant, will also be very, very small. Okay, so dealing with weak electrolytes now, or a weak acid. Dealing with a weak acid now, how do we determine the equilibrium constant? The equilibrium constant for the dissociation of a weak acid is otherwise known as acid dissociation constant. So acid dissociation constant is also an equilibrium constant, only that we are relating it specifically to a weak acid. All right. So the reaction of a weak acid with water, it forms a dynamic equilibrium involving hydrogen ion and the conjugate base A minus, such that the equilibrium constant, like I said, is called the acid dissociation or acid ionization constant. All right. If you look at this expression carefully, this is how it should be, because this is what we have. Let me write what we have really here. So we have the acid, sorry, please. Okay. All right, so let me write it here. This will actually happen in solution. So we have HA, that's the weak acid dissolving in water with a liquid, and of course an equilibrium is established. We have H3O plus plus A minus. All right, we can write this also in this form. We can write this as HA dissociating to, because what we have here is actually, okay, maybe I should, I should, okay. All right, I'm coming, let me just, okay, so let me write what I'm meant to write before. H plus A minus. Why do I say this is equivalent to this? I will explain. Because what we have here, the H3O plus is actually H3O plus is actually H plus that is hydrated. Okay, so that if this water is taken away, this water is taken away, we are left with this. Okay, so it could be written. So you will notice that along the way, I could be using this interchangeably. Okay, I'm only saying that they are essentially the same thing. Okay, all right. So so the expression according to this particular one here is the equilibrium constant is this. We have H3O plus A minus, and of course H2O liquid and HA in aqueous. All right. Since the concentration of this is fairly constant, we remove it. And of course, if we remove it, we're going to be left with the expression for this. That's why I say they can be used interchangeably. Okay. Okay, so the concentrational terms for pure liquids and of course solids are equal to 1, and they do not appear in the equilibrium expression. So the acid dissociation constant becomes this. I said as earlier discussed, sorry, I've not discussed that. Now, really, it was an, it's an omission. I actually wanted to share with us the various types of equilibrium. We have homogeneous equilibrium, and we have equilibrium. I'll find time to teach that before the end of this class, perhaps in our next class, before I continue with acid-base equilibrium. All right, so let's put that in abeyance for now. Let's continue with this lecture as it is. So, okay, I've explained all this. That's what I've explained above here. The acid dissociation constant for weak acid, range over many orders of magnitude, so let's say example of what I'm trying to say in the next slide. Okay, you can see here the table are presented when the Ka is relatively high, such that the percent dissociation is about 10%. Can you imagine that? Even with 10% dissociation, the Ka is in the neighborhood of to the power of -2. I can see for chlorous acid, it's about 10% dissociated. For if it's moderate, for example, acetic acid, you have in the range of -5, where you have about 0.33% dissociation. Then, of course, if it's extremely low, like you have in HCN, hydrocyanic acid. Now, this is an interesting acid. If this acid is present, even though its dissociation is very, very low, if this acid is present in its food substance, it dissociates rather to cyanide ion. Now, the percent cyanide ion from hydrocyanic acid is extremely small, but as small as it is, it will be very, very lethal. It can kill instantly. Okay, that's why this study is very important. I don't know whether you have heard of cyanide poisoning. This is when we say cyanide poisoning, we're talking about the cyanide ion that is formed from hydrocyanic acid. Like I said, so for example, Gary, I'm sure a number of us are familiar with Gary, a staple food in Nigeria. If not well fermented, such that the hydrogen cyanide had been significantly reduced, consuming a non-fermented Gary cassava can lead to death. Okay, and you've heard of people eating fufu and dying, and that's why how many Ijebu are in the class? If you're an Ijebu person, clap for yourself. The Jebus are the experts in making gari that are very, very low in cyanide ion. That's why the gari, one gari Jebu, or koleno, because they are processed in a way that the cyanide ion is drastically reduced. So, I'm recommending, if you want to take gari Jebu. Anyway, that's on a lighter note. Now let's continue to our lecture. Why we want to continue with the lecture, I would like us to take our attendance code now. The first code for today's class is, I'm going to write it here. I'm going to write it on the screen here so that everybody can see it. Let me write it here. Is 9 D X A B. 9D XAB. So please log in for your attendance now, please. All right. So let's continue. So for solution of initial small initial HA concentration, the smaller the Ka value, the lower the percent dissociation of the HA. So for weaker acid, lower, it implies lower percent dissociation of HA, which of course will imply smaller Ka value. Now, water. Now that takes us to another important definition of acid and base. Now there's a definition called the Bronsted and Lowry concept of acid and base. Bronsted and Lowry concept. All right, in this concept of acid and base, an acid is defined as a proton donor. A proton donor, that's an acid. While a base is defined as a proton acceptor. A base is defined as a proton acceptor. Now, water. Water can behave at the same time as a proton donor and at the same time as a proton acceptor. A substance like water that can behave as a proton donor and a proton acceptor at the same time is said to be an amphoteric substance. It can behave as an acid, it can behave as a base. And so that's why we can say that water can auto-ionize. Water can auto-ionize. I'm going to look at that in the next slide for us to comprehend that better. Okay, that's what we have here. I'm sorry, the equilibrium sign is missing here. I guess I can write it. I can write here just to illustrate what I'm trying to say. So we have H2O, a liquid, reacting with another H2O, a liquid, to give us. Now, if this one is donating proton to this, then you're going to have H3O plus, now becomes aqueous. And because it had donated proton, it's been stripped of a proton, so you'll be left with OH. So the proton comes here to become this, and what is left here will simply be plus OH minus. Okay? This is what we call auto-ionization of water. Now let's look at this carefully. Here, if we call this the acid, of course they are the same. If you call this the acid, this acid is donating proton here. And to form this is accepting the proton to form this. So this acid, okay, is being stripped of proton and become this. So if this is the acid, then it's going to be the corresponding conjugate base. Okay, now this is a base because it's a proton acceptor. If this is accepting proton, this is the base now, and this now be the conjugate acid. So in the Bronsted definition of acid and a base, there will always be the acid, the conjugate acid, the base, and the conjugate base. Now, so the equilibrium constant for this reaction is called the ion product of water. Okay, ion product of water, and that's what you have here because, like I said, it's a very, very weak reaction. The value is 1 times the value for Kw at 25 degrees Celsius is 1 times 10 raised to the power minus 14. 1 times 10 raised to the power minus 14 to show us the extent of this dissociation. So in one word, since the value is extremely small, we can say that this does not change appreciably in solution, and so that's why we write the Kw in terms of the ions from. So that's why we call them ion products of water, or the dissociation constant of water. All right. So since the value is 1 times 10 to the power minus 14, and according to the stoichiometry of the reaction, the amount of this in solution is equal to the amount of this in solution. Let's call it XX. So we are saying that 1 times 10 to the power minus 14. We're saying that 1 times 10 raised to the power minus 14 is equals to X times X, which of course will be equals to X squared. X is the concentration of hydrosodium ion, which is also equals to the concentration of hydroxide ion. All right, so if you find the square root of this, you find out that X, so this will imply that X will be equal to square root of 1 to the power minus 14, and that is 1 to the power of minus 7. So in any aqueous solution, the product of the concentration of hydroxonium ion and hydroxide ion is always a constant at 25 degrees Celsius. Okay, and if the concentration of hydrozonium ion is equal to that of hydroxide ion, then you have a neutral solution. So for a neutral solution, therefore, the concentration of hydrogen ion is equal to the concentration of hydroxide ion, which is equal to 1 times 1.0 times 10 to the power minus 7 molar. That is for a neutral solution. However, in any aqueous solution, be it neutral, be it acidic, be it basic, always the auto-ionization of water is always a constant. That is, the product of hydrogen ion and hydroxide ion concentration is always a constant, 1 times 10 to the power minus 14 at 25 degrees Celsius. And that's what this is all about. So for a neutral solution, hydrogen ion is equal to hydroxide ion. In acidic solution, hydrogen ion is greater than hydroxide ion. And of course, in basic solution, hydroxide ion is greater than hydrogen ion. In all cases, the Kw is always a constant at 25 degrees Celsius. Okay, to illustrate this concept so that we can have a feel. So that we can have a feel of how to solve problem with this. The question says a research chemist adds a measured amount of hydrogen chloride gas to pure water at 25 degrees Celsius and obtains a solution such that the hydrozonium ion concentration is 3 times 10 to the power minus 4 molar. Calculate the OH concentration, and the question is the solution neutral? Is it acidic or is it basic? All right, let's provide an answer to that. Okay, 3.0 to the power minus 4. Okay, so what are we given? Given that the hydrogen ion is equals to, let me quickly go back to the next slide, the previous slide, 3.0 to the power minus 4, okay? 3.0 to the power minus 4. We are asked to determine the hydroxide ion concentration of this solution. We know, so I can say remember or recall that Kw is equals to H3O plus and OH minus, which is equals to 1 times 10 raised to power minus 14. So we can say, therefore, that OH minus will be equals to 1 times 10 raised to power minus 14 over H3O concentration, which is equals to 1 to the power of minus 14 over 3 to the power of minus 4. It's not everything you have to use calculator for. You've got to be smart, okay? Without wasting time, you will know that this is exactly equals to 1 over 3 times 10 raised to power minus 10. 1 over 3 is 0.333. And so this simply becomes 3.33 to the power of minus 11 molar. So that will be the hydroxide ion concentration. Question: is the solution neutral? Is it acidic? Well, we know. To be sure, is the hydrozonium ion greater than the hydroxide ion, or is the hydroxide ion greater than the hydrozonium ion? Since the hydrozonium ion is 3 to the power minus 4, and the hydroxide ion is 3 to the power of 3.33 to the power minus 11. So we can say, therefore, in this solution, the concentration of hydrozonium ion is greater than the concentration of hydroxide ion. Hence, solution is acidic. Hence, solution is acidic. Okay? So that's a very simple question, just to illustrate everything I've been saying so far. Let's make progress. The solution, excuse me, please. All right, so we are asked now, let's take a challenge on our own. Okay, the solution is already it's already on the slide for you. I just, for interaction, that's why I have to solve it again. So let's make progress. And so in this next slide, you're asked to calculate the hydrozonium ion concentration in a solution that has OH concentration of 6.7 to the power of minus 2 at 25 degrees Celsius. Question: is the solution neutral? Is it acidic or basic? I'm sure you should be able to do that with relative ease. All right, now let me progress. Now, you can see we've been dealing with numbers with negative exponent. Now, to make it easy to deal with numbers with negative exponent more conveniently, we convert them to positive numbers using what we call the p-scale. The p-scale is simply the negative of the common logarithm of the number. So if we apply this to the H3O plus, p-scale, that's P of hydrogenium ion concentration, is known as pH. So the pH is simply the negative of the common logarithm of hydrogen ion concentration. Okay? So the question here is, what is the pH of a 10 raised to power minus 12 molar hydrogenium ion solution? That's to be very easy for anybody to do. And so we say pH is minus log to base 10 of the hydrogen ion concentration, which is equal to minus log to base 10 of 10 raised to power minus 12. Don't forget what we have here. don't forget, in your logarithm, secondary school, something you were taught, for example, if you have log to base A of A raised to power B, and that will be equals to B log A, log to base A of A. Log to base A of A is 1, and so the answer is simply equals to B, and that's why the answer A is simply equals to 12, because it's minus 12, and you have a minus at the back, and that's you have plus 12. Okay. And as we have discussed this, I don't have to waste my time on that. Acidic solution, the pH must be less than 7. For a neutral solution, the pH must be equal to 7. For a basic solution, the pH must be greater than 7. These are familiar terms. So let us make progress. All right. So we can also, of course, use the P scale to express other quantities as well. We have pOH, we have pK, we have pKa, and so on and so forth. All right. So I think that should be okay. Let me now dwell on for weak acid and weak. Okay, we're looking at weak acid now. So now we have written that the equilibrium constant for a weak acid. Okay. So if we have the equilibrium constant, let's say, for example, for acetic acid, let me say for acetic acid, Ka for acetic acid, CH3 COOH is equals to 1.8 to the power of minus 5. I want to write that down. For formic acid, if my memory will serve me right, for formic acid, that's what we call metanoic acid. Okay, the Ka is I think it's about 5 to the power of minus 4. Okay, I'm not too sure, but I know it's power of minus 4. All right, now let's compare these two. Now, pKa for acetic acid will be equals to minus log to base 10 of Ka of acetic acid, 1.8 to the power of minus 5. I'm trying to use this to illustrate an important point. Let's quickly do that together. You bring out your calculator. I have mine with me. Okay. I'll give them that. When we are done with this, I'll give you the second code for attendance. Okay, so we have log to base 10, okay, 1.8 exponential minus 5, and that will give me 4 points. That for this give me 4.74. I want to be following what I'm doing. Now let's look at for formic acid. 5 exponential minus 4, and that is 3.3. So for formic acid, let me write it here. For formic acid is 3.3. For acetic acid is 4.74. You can see that now, that when you have a IK value, this is higher than this. A IK value will correspond to a low pKa. As you can see, 5 to the power minus 4, the pKa is 3.3. Now, here, Ka is 1.8 to the power minus 5, the pKa is 4.74. Okay, so the lower the Ka value, the lower the Ka value, the higher the pKa, and vice versa. I just want to see that. So we can say, therefore, that an acid that has a low pKa is a stronger acid than an acid that has a higher pKa. I want that to sink into our mind. An acid that has a low pKa or a lower pKa is stronger than an acid that has a higher pKa. Conversely, an acid that has a lower Ka value is than an acid that has a higher Ka value. So you can see pKa and Ka can be used interchangeably. You could have questions like that, and you are given the pKa value of some series of acid and asked to arrange them in order of increasing acid strength. You should be able to know that with relative ease. Having done that, shall we take the second code for today attendance? I'm going to write it on the screen. Is X in capital, C, N, V, N, all in capital. Okay, xylophone, Christmas, network, Vera, Madonna. Okay, so that is that about that. So let's make progress. Please log in and log in the attendance, please. We are making progress today. Let me your feedback. Let me see your feedback. Attendance form is not opening. Why? Try and check it very well. I can some of you saying that the attendance is not opening. Okay, please look at it carefully. I'm sure there shouldn't be any problem with that. Okay, attendance. All right. We'll see. We'll look at that before the end of the class. Okay. Okay, it's open now, please. Please check. Yeah, check now. I can see your complaint. Don't worry. Check. You see, we want to make life easy for you. That's why we doing this so that you don't have to congest together in a very small venue. Okay, the air to raise can everything associated with bringing you a large number of students together is what we're trying to guide against. That's why we are doing this. Okay, so let us cooperate with the university to make it easy for us. Okay. Okay. All right. So the attendance is open. Please look at it. Let's see how far we can go. All right. So we want to establish an important relationship. We have said that in any solution, the products of hydrogen ion and the hydroxide ion is equals to 1 to the power of minus 14. Do you remember that? All right. If we take logarithm of both sides of this expression, we have that log of the products of H plus OH minus must be equals to 1 to the power of minus 14. Oh, sorry, log, I should take log of that too. Sorry, let me clean this so I can rewrite it quickly before we run out of time. Okay, so what I'm trying to say is that we have established that H plus OH minus for any aqueous system is 1 to the power of minus 14. So if we take logarithm of both sides, we have log of the product of H plus OH minus B equals to log, don't forget it's log to base 10, of 1 to the power of minus 14. Okay? This, of course, will be log H plus log OH minus will be equals to minus 14. Multiplying all through by minus 1, so we have minus log of H plus minus log of OH minus will then be equals to 14. Will be equals to 14. By definition, we have said that this is the P scale, so this will be pH plus, and this is POH, will equals to 14. So for any aqueous system at 25 degrees Celsius, the sum of the pH and the POH must be equals to 14, just as the product of hydrogen ion concentration and hydrogen concentration is equals to 1 to the power of minus 14. Okay, so that is a very important relationship you need to take note of. Okay, now let's look at for strong acid. That's when we'll stop for today. How do we determine the pH for strong acid and strong bases? Okay, for strong acid, the equilibrium concentration, of course, is actually not an equilibrium process anyway, since the reaction goes to completion. So we can simply say the concentration of hydrogenium ion concentration in solution is equal to the initial concentration of the strong acid. For example, 0.02 molar HCl. Now that is for a monoprotic acid. Please don't let conclude like that. Okay, for HCl, HCl, we ionize completely to give H plus Cl minus. So if you have 0.2 of this, then by the time it ionizes completely, you're going to have 0.2 of this, and nothing of this will be left in solution. However, if you look at a diprotic acid, because it's important to emphasize that, let's look at a diprotic acid like H2SO4. Let me write it here. I'm finding it difficult to write at this point. So let's look at H2SO4. Okay, if it ionizes completely, it's going to give us 2H plus SO4, 2 minus, such that if we start with 0.2 of this, by the time it ionizes completely, there won't be any of this anymore. But what we have here will be 2 times, that'll be 2 times 0.20 molar for hydrogen, which is 0.40 molar of hydrogen ion. All right. I'm sure the attendants, you are okay. Thank you. All right. I can see for a lot of you, it's working. That's very good. That's very good. That's a good comment. Okay, let's take the last attendance because we have barely 3 minutes more to the end of this class. We have barely 3 minutes more. So I'm going to write the last code. And please, you have only 2 minutes you have just 2 minutes to put this last code, because we will not allow you to do that immediately. It's 10 a.m. So it is 823 CV, 823 crystal violet, capital C, capital V. Okay, I think that's a good point to call it a quit for today. I hope to see you again Monday morning, God's willing. Till then, have a wonderful weekend, and you can then go around and jollificate with your senior colleagues that are doing convocation today. Rice and spoon, very plenty. See you on Monday. Bye-bye. Hmm? Please submit your attendance now. You have just a minute more, please. You have just a minute more to submit the attendance. Thank you very much. God bless you too. Thank you. Yewande Anna, it's working. Oh, wherever you are, it's working now. And you have just a few seconds more. It's working. Wherever you are, Yewande Anna, I can see said it's not opening. No, it's open. It's open because a number of students are already submitting their own. We have few seconds. We're going to give just like a minute more, not more than that, please. All right. Thank you. Bye. I'm continuing that class next. I didn't finish the slide. It's quite much. My accountant general. Sorry. Class. That's all. How are you? Okay.
Hello, good morning, everyone. I'm sure you can hear me. If you can hear me, please, I would like the class reps to say hi on WhatsApp, and then I'll quickly that you can are together. So let me check if there's anything like that. Okay. So if you are for AMS 103 and you can hear me, please, can you just type in the chat box to have your feedback? Okay. Okay, I think you are here. I can hear you, madam. Thank you. AMS 103. Okay. And then I'm sure it's my students that are responding, not the student that just concluded a lecture now in the sciences. So I assume you are with me. Okay, thank you. Before we start sharing the slides, I would like to remind you of the fact that I'm not the only one taking you through. So we are three. Myself, Dr. Adeton. I'm not sure you've met her. You will still meet her. Then Mr. Debisi. Mr. Debisi is, so Dr. is there. Please, she's with me in the studio. You can see her in the teleconference room. Yes, so say hi to them.
Hi, good morning. How are you doing?
I want to see you react in the chat box. So please. Okay, so someone is saying it's not working. What is not working? If it is not working, we shouldn't see your slide. I mean, your messages. Yeah, so it's working. So you can see the two of us, myself and Dr. Adeton. So we'll be taking you one after the other, but we are together here, and we will continue to be together. So if you are having challenge logging in, please can you seek assistance from your friends, and then we can be on the same page. This is quite important because we'll be at intervals. So please, I wouldn't want you to miss out, and then notify others who perhaps have been carried away with the celebration of a induction, convocation ceremony. Yeah. So we will soon release you by 12, no, even before they finish the ceremony, and then you can felicitate with them, eat your rice, chicken. Okay, thank you. So it's quite important for you to always be here. I think our slide will come up any moment from now. No, AMS 103 is titled Introduction to Computing. And then if you, definitely I will share the course content with you and the objectives, the general objectives in the course, so that you can appreciate that we are a little bit delving outside of our comfort zone in management sciences, and now we are coming in, peeping into what is going on out there in the computer world. That's computing, engineering related and everything. So generally, I want you to understand that this is very important because the walls between individual or different fields of studies that had existed for ages have recently collapsed due to massive advancement in technologies. So these days now, you cannot fold your hands and say, oh, I am an accounting student. I have nothing to do with the computer science students or engineering students or those in sciences. I don't doing. I hate physics. I hate chemistry and what have you. So the story has changed because in your world today is the world of technology, and I know you are up there, but no, because you will not only be engaged chatting on the social media networks, there are several other important organization-related usefulness of computer for which it was primarily made that you need to learn. So that's why we are here, even though you are not a computer student. So then today, at this introduction, we'll be looking through the historical background, that is the history or evolution of computers, of course, part of the introduction to computing. And then we're looking at some programs in computing, as well as the relevance of this to our study while we are here. So please get seated and be ready to learn. Of course, my name is Mary Salawu, a professor of accounting, not a professor of computing. Okay, so you are not going to crucify me to say, but my dad is a professor of accounting. She's really not speaking as a computer scientist. I am not a computer scientist, but I can't fold my hands. I'm also learning, just like you are. I'm learning, and because this is the reality of our world. And so to be relevant, and of course, even our profession, to be relevant and be able to deliver our services, despite all the other skills that we have that, those in sciences or computer or the engineering cannot boast of. We also cannot function or be at our best or meet the needs of our users if we neglect this primary preliminary study. And of course, you can build on it. So kudos to NUC for introducing this course into the CC Mass for our management sciences students. So once again, I want to welcome you. Please take your seat. Please let me confirm if my slides are already here, and then we can enjoy the sessions together. Yeah, hold on a little. Okay. So just 2 minutes, you will see the slides. So computers, as you know, have existed, of course, even before you were born. So for you, it's it's not a new thing, it's normal. But for many of the older professors all around here, and other older colleagues, they never saw computers throughout their primary school days, secondary school days, even university, even working, they never saw anything like that. So some of them, that's why today you can't blame the older generations when they struggle to operate some of the devices. So you don't make jest of them to say, but he's a professor, he does not know how to handle this. No, it's your world. So you have that role. In fact, you should know more and then teach and also influence others. So still waiting for the slides to come up. Please, I think this is just peculiar to today. For our subsequent meetings, the slides will be right here. Okay. The class rep for accounting, you have told me that something else was showing. I want to believe you are no longer seeing anything aside from the interaction we are having now. So otherwise, please let me know. Okay. Let me check your response. Okay, good morning, ma. Okay, yeah. Please, code. No, you wait for the code. We share the code for, this is AMS 103. So the other is not chemistry. So if we release any code now, the code is not for chemistry students. It's for management sciences, social sciences, and all. I mean that we are here together for AMS 103. Okay. And now, those who are not around the campus, we agreed that the campus, I mean, the lecture is transmitted to you via the teleconferencing, which relies so much on local area network. So that's why, of course, you could be in your room. That's not a problem, but just find a comfortable place to receive the lecture. But those who are outside, it may be a little challenging for them. They will not be able to. So please don't try to send the code to those who are not part of this lecture. Are you with? Yeah, thank you. So if you do, we can always detect, because at the back end here, we know the people that attend. So you only do them harm, more harm than good. So if somebody is not part of, because as you log in and log out, if you log in 3, 4, 5 times, the system takes note. I shared the instructions with you earlier. I'm sure your class rep had done that. So you've read it through. So that is it. So don't try to play pranks. And then you want to play smart, and a friend who is in Lagos or in Abuja, so then you are quickly sending the code, please register. No, that is not done. So you end up, not helping your friend. Okay, in the meantime, let me quickly run through the learning outcomes. For the learning outcomes of this AMS 103, it is expected that at the end of the whole course in this semester, you as an individual should be able to explain basic concepts of computing and different programs in computing science. So not in management science, in computing science. So that's why I told you we are, going. It's just like we are on a journey. So we have left our comfort zone, and now here we are in another field. So we want to see what is it, what are they doing there? Can we also understand their language? So that's why I'm sure you will definitely understand their language, even if not the core or the hint, at least. So when they speak, you can respond accurately and reasonably. Thank you. Again, another learning outcome is for you to be able to explain hardware and software and the functional units of computer. So we will go into details of this, not today, but for you to know what to expect. Another learning outcome is to describe information process and its roles in society. So anything, any knowledge, any innovation that does not benefit the society is more or less worthless. So because we are living to serve and to meet the needs of our society, sometimes you think for the society, and of course sometimes you also have to meet the immediate needs. So whether latent needs or immediate needs, and whichever way, we'll be able to relate the roles of our learning here to the immediate society, particularly in our field. Okay. Again, you should be able to illustrate how an operating system kernel supports the execution of programs. So you can see now, I told you, we are going into a land that you have to open your eyes, open your ears, and see, because I'm sure some of you have not learned anything about writing codes or writing programs or writing algorithm before. Of course, we are not taking you into the in-depth, but just the simple ones, and see how, some of these operating systems work, with the hardwares and everything, to ensure that the goal of the user is achieved. Okay. Okay, so here we go. You can see the learning outcomes being displayed in my second slide. That's slide 2. Good. Okay, thank you. So if you can see, let me wait for you to tell me if you can see. This is AMS 103 class. Some people are still asking which class is this. you can log out if you are not for AMS 103. Thank you. Okay, so you can see my slide, please. Can we go to the next slide? Okay, yes, thank you. So from the next slide, the basic concept of computing and different programs, hardware, software, I've told you, describe information processing and its role into society. So then the next slide to this, wait for it. You should see the next slide now. Don't worry, the network is breaking, it will stabilize. I think it's even the network that is not allowing you to see the next slide. So in the interest of time, please, we'll see how to still navigate through, since you will definitely see as the slides run. Please pay attention and then don't get carried away by network. It's one of those teething problems we experience and then we struggle with on this side of Africa, so, and it's not peculiar to Nigeria. So please bear with us. So again, you also need to be able to do some practical work. You need to carry out some, so no, you can't do the practical if you don't understand. So slide, I think we should be on slide 3 now. But this is slide 5. We can go back to slide 3 and then 4. This is slide 5. Anyway, so you'll be required to do some laboratory assignment. Definitely, we may not necessarily, because I'm not sure we have the facilities to take care of all of you, to put you behind the computer system in the department or the office. But of course, on your own, you can make do with your own devices and then learn some of these applications that are relevant to us in our field. The next slide. Which is slide 4. So now we are moving to the historical perspective of computing. Yeah. So as far as the history is concerned, now computers, since its introduction, had been now grouped into different phases that we call evolution, beginning from the very first set of computers, that existed and then made use of a vacuum tube, and then was very slow, and then generated so much of heat, and then used punch cards, and then occupied a very massive space, in the office or in the room where it's be placed. And again, you have heat, not very slow, of course, I said. So if it's very slow, you can imagine how inefficient it will be to handle massive production that will be required for economic or organizational scale. So these were some of the challenges, and of course, very expensive, for people to acquire. In fact, who would even acquire, because people did not have the knowledge of how to actually operate it, except for the specialists. So those are computer engineers and experts. You also realize that one of its future was that it's relied on machine language. So what do we mean by machine language? Machine language is the language that is much understood by the computer, and which is in binary form. of zeros and ones. And so the instructions were written in zeros and ones. So if you want to write your name, for example, can somebody type his or her name on the chat box? I'm watching out. Let me see. Somebody's name. Let's see somebody's name. I'm waiting.
Yes, sir.
Okay, so I can't see your name. Okay, I can see someone's name here. Akindun Tire Emmanuel Olamide, thank you. Dada Mubaraka, thank you. That's okay. John, yeah. Now let's use John. You know, John is John. Now, in those days with machine language, written in zeros and ones, J will be a combination of zeros and ones in different arrangements that the system will understand, then the whole, then the H, then the head. So to write John will be in zeros and ones. It will be 0, 0, 0, 1, 1, 0, 1, 1, 1, 0, 0, 0, 1, 0, 1, 1, 0, 1. I mean, something like that. So it's very difficult for a human to comprehend. Okay. Please, can we move to the next slide? Yeah. We want to move to the next slide. So you've seen the picture there of how the first generation computer looked like, unlike what we have today, that everyone carries his own laptop of different sizes and capacities all around. Okay, and then so we are moving there. So historically, so see how vacuum tube look like, and then it's embedded into the first generation computers, and then to take so much time, and then of course it will generate results. But then with all the characteristics and the features I have indicated to you, you know the challenge that the scientists, computer scientists then had to face. So the next slide. So you see another picture of the vacuum tube arranged. You can see it. Yeah, how it looks, you can see it. So you even look at it very closely, you are like, oh, what engine is this? So for individuals to have these or hold these, or I mean, so you can see, you can appreciate the much difference that we talk about in our day. So move to the second generation computers. Of course, for the first generation computers, the year has been indicated. Of course, you may not find some consistency if you go online to look for maybe information. But for the first generation computer, you have from 1946 to 1958. And then now for the second generation, you have it spanning between all the computers that we have made between 1959 to 1964. So it was at this second generation existence of computer that we had something different from vacuum tube that actually enhanced the operationality of computers. That is the transistors. So for transistors, life became easier. Speed, it was gained. The size, the heat problem, was a little overcome. And then, I mean, some of those challenges or peculiarities that serve as the limitations to the first generation computers, we are reduced, or we are more or less eliminated by the existence or introduction of transistors. Now with this, the logic of using and or and all that was introduced, and then of course it also serves as the gateway, for moderating the electrical flow, into the system, and then you can have this on and off, in the operation of the computer, different from when it relied solely on a vacuum tube. This, of course, still relied on low-level language. So the low-level language is also computer language, that is not easily understood by humans. So in comparison with that, we have a high-level language. High-level language is the one that's readable, like you can say go to, write, print, uh, add this and this, you can see. So it's easy for you to read all that. So that's high level language, which is very close to human language. So these second generation computers are faster and then they are cheaper. And of course, they can allow many applications to run at the same time. Examples here are COBOL, Fortran, of course. Yeah, COBOL, that's a common business-oriented language. And I remember a few others, maybe C2 was part of it. And then DBase, yeah, DBase 1, 2, 3. And later we had another version. And today now we talk about Java, we talk of uh, Python and several other ones. So things have changed. So please let's move to this next slide. So yeah, look at the picture of a transistor. Yeah. So next, yeah, so you can see it's not as massive as the other one we had, and then you can see Office is neater. The operator can place it on the table, unlike the one that we occupy the whole room in the first generation. Please, the next slide. So we move to the third generation, which 1965 to 1970 with integrated circuits. So with this, you have a better life using computer. It allowed the running of many applications at the same time. It's smaller in size. Also the mini computers also were already introduced in addition to the mainframe computers which existed earlier during the second generation, and then they are faster, much faster, than the one with the transistors. So you can see from generation to generation, there is a kind of enhancement and improvement, and which is much beneficial to the users. Of course, increased memory capacity. So you don't have to store what the result is that your application has generated. You don't have to store it in your head. Computer has its own head that can store all this, and then at the tip of finger, just issue the command immediately. It gives it back to you whenever you need it. Okay, so this time around in the third generation, the computer made use of high level language. I explained that to you. For high level language, you can now introduce some readable words like do or had or this plus that, or if this then that. You can see, so it's very close to human language, and even if you are not an expert, you can appreciate what the instructions are all about. Please, can we move to the next slide? The next slide. Okay, so you see the integrated circuit here. And then let's move to the fourth generation history about the fourth generation. So for the fourth generation, historically, you have it from 1971. For some, they say it's till date. But of course, you also have some historian telling us that, okay, is stopped at 1984. Please, can we move to the next slide, please? Fourth generation computer, 1980s rather, sorry, 1971 to 1980 as a cutoff, because as we speak now, the fifth generation computers are everywhere. So it may not be correct to say it's from 1971 till date. But of course, the reason for that argument, of course, is very understandable, because the components of the fourth generation computer, which is the microchip, and the integrated circuit, in addition to other enhancements, are still part of what we use even in this fifth generation. So that's why some say, oh, okay, for fourth generation computer from 1971 till date. But with the massive advancements these days now, you can see that clearly there is difference between what happened in 1970s, 1980s from what we are witnessing today, okay? So it makes use of integrated circuit and microchip, which is smaller in size, and then the reliability of the computer usage, of course, has increased. And then, yes, microcomputers, in addition to the mini and mainframe already in circulation, of course, we are also available. I explained to you already what high-level languages are, and so you have more of that. And then computer now became interactive. So, and even today we have it to be more interactive. So you might not even have learned an application before. You just log in into the website, then you can interact with it as if it's a friend chatting with you. So this idea had been embedded right from the fourth generation of computer. So then, I mentioned DBase to you the other time. So you have DBase 2, EHS, and all that. Spreadsheets. Today now, the spreadsheet now has a lot of enhancement and advancement. In fact, is AI, active today. And so you make use of all these applications just to meet the needs once you learn the skills. And so that's why I'm saying don't limit yourself to what we are doing right there. Of course, we are not training you to become computer scientist or expert, but you must avail yourself to learn more and go beyond what we are doing here, because you actually need it. In fact, I would advise during your holiday and maybe the first semester break, instead of running home to go and eat chicken and what have you, and then you are adding weight, please come and add to your knowledge. Come to computer center here. They have incubation center. They call it incubation center. They have a business engineering, I think, a center. So they have some of these facilities and provisions for you to come and learn, and then you can make our world better. So of course, at this point, the cost has reduced tremendously. So the cost has reduced in terms of purchase. So you have IBM 360 series, readily available for purchase and being used by different organizations, for example. So unlike what existed in the first, second, or third generation, please, we can move forward. Thank you. The next slide. Yeah. So you see here, so please move to the next slide. Another one, yeah. Thank you. Now to the fifth generation computer. Yes. Here we are. How did it start? The goal for developing devices that can act, work, perhaps think like human without any human intervention. So that was the goal, that was the drive. So with that motivation, the scientists and the engineers sat together again and then put the algorithm together, so we can make this thing work. We don't have to even go there. We can make it work, and then continuously it runs, the applications to achieve the goals and all that and all that. And today now it's evident, so you really understand what I'm trying to say, but I'm telling you that it started from somewhere. So then the system, that is the devices that will respond to natural languages as inputs. Today now, I can speak my language to the computer and then ask it to interpret. So you have that already happening, okay? I can write a manuscript in my language and ask the computer to interpret to 5, 10, 50, 100 languages, even outside my continent, okay? And that is also possible. So the computers of these fifth generations are capable of learning. They can learn. They have the capability to learn by themselves. Self-learning is there. And then self-organizing, okay? And then it's no batch processes, when to do what, the instructions are being issued, and then it unfolds and executes at the right time. So you can see how much computer is really enhancing our operations in different facets of life, okay? So that's the more reason, again, I will come again to my point that you must get interested, much more interested, because I don't know of any sector in any economy, whether in Africa or anywhere in the world today, that technology does not affect the type of innovation, productivity, and what have you. Okay. So some of the features, we still get to see more features: knowledge-based management, high speed, very high speed, introduction of microprocessor that can be controlled by robots. So today now robots are here and there, go to the hospital, they are there, go to restaurants, they are there. So then you see robots now diagnosing illnesses and making recommendations to the clients. You see some of our older people wearing some call them wearables, and then like sometimes it will be like a wristwatch. It is not just a wristwatch. So many applications have been embedded into that so-called wristwatch, which you think it is, and I said it is not. So from there, the person can monitor his temperature, it can measure his high blood pressure, and then the system can quickly tell or advise, oh, you need to quickly take your leave now. You have been sitting for 3 hours. It's not good for you. Please take a walk. So you can see now, people, I mean, telling you, okay, you have labored so much now, your high blood pressure is this level, so this is dangerous for you. Please, can back and rest. Okay. So right in the real time. In fact, I'm sure. So for many of you today, you are doing self-medication, you go online, maybe you are having some, you are feeling something in your stomach, and then instead of going to the health center, the university has made provision that, oh, register. Most of you, maybe, I don't know, maybe more than 50% of you don't even do the registration at the health center. Okay. And then maybe when you now need help, you quickly rush, "Hey, take me to health center," and then you are struggling. But why? It's because there is something you feel you have. You feel you can get help faster than you get to the health center, because right on your device there, you can put a feeling of burns in so part of the body, or a feeling of ache, or pepperish feeling, or sharp pain on this side of the body, or headache at this side of the body, or if I eat this, I mean, you can see. So this is the practicality of it all just before us. So in the law profession, you see computer serving as personal lawyers, providing legal advices to clients. Okay, and then we found that even some of the advice are as accurate as the experts in the field. Okay, so the same way we use it also in okay. So we move to this next slide. You see a hand holding a pen. That's not human hand. Okay. Yeah, so you can see this is a robot. Okay. So now can write, can do this, can teach. So I'm sure you are aware that there are schools where they don't need teachers. Now, no physical teachers are required, and then it's just the robot that teach the student and they learn. Okay, please, the next slide. So you have them in different sizes and structures, depending on how you want the outlook, and then the services it will perform for you are some of the very difficult tasks, that individuals could not do, exposing them to risks and dangers like exploration, like going down, drilling down, down, down. Today now you can just send the robot to do the work, and then there's no loss of life. I mean, and it can work tirelessly and then be there for days. And so these are some of, please, the next slide. These are some of the benefits we enjoy in this era of the fifth generation computer. So we'll see some of the features. Yes, artificial intelligence. Today now the machine, we learn, we reason, we solve problems, we provide solution, make recommendation to you, and ask her, interact with you, engage you. Okay, if you use this generating power, that's a chat GPT. Yeah. So you see it, you put a question there, then it's coming back to say, oh, thank you, that's good. Then it mentions your name, and then it say, do you want this or you want me to do that? So you can say it's reasoning. And then it's okay, do you prefer this other one? Don't you think this will help you? Because it will study you over time with some of the questions you pose, whether you are a student or maybe a trader or a scientist or administrator or a lawyer and all that. So it brings some suggestions, and then those, can predict some of what you are likely going to benefit from, and then push them to you on your device, and then you pick. In fact, for some, you appreciate, oh, this has come up, oh, I'm not aware of this. And so that is it. So it reasons, it helps, then machine learning systems that improves performance through experience. So that is part of it. So it learns, and then recognizes, then store information, and then the more the information, the more the more frequent, it gets this information, and then the volume of the information, accuracy of what you feed the computer also with, in this era, in terms of machine learning, also will really help in helping the system to learn and to perform at its optimal level. Parallel processing, that is multiple processors working simultaneously, doing computations and generating results immediately. Ultra large scale integration, see millions of transistors on a single chip. So this quite different from what we had in the first, second, third generation. Natural language processing, we have shared that, can speak your language, speak Igbo, speak Hausa, speak Yoruba. It will pick it and then interpret for you. Okay, applications, we have seen it in healthcare, said not about that. In finance today, now you do banking, you sit down at your home. Unlike in the past, that we will have to visit the bank and join a very long queue, spend 1 hour, 2 hours, and later 3, 4, 5, and then it doesn't get to your turn. Then you come back the second day, and then the sun will scorch you, and then you feel hungry, you miss appointments. All these have been done away with, because today now we have the system that okay, please, okay, don't worry, you can remain here. So these are some of the areas, the applications. I was talking about the finance, and then we talked about the legal. We've talked even in I've talked about other aspects. When you are trying to protect people from some risks, exposure. Machine can do the work for you. You want a continuous, where human beings can experience fatigue, and then please, let's still be on. Okay, no, we can continue. So please, weather forecasting, this is happening, scientific research, all these are made possible today. We can move forward to the next slide. So here you see some of the features, okay, and examples of the fifth computer generation. So IBM Watson is an AI-powered system which is famous for winning Jeopardy and is being used in healthcare analysis. Okay, here I say is Fujitsu K supercomputer. Is known for high-speed parallel processing. Deep Blue also is another IBM product, defeated world chess champion Garry Kasparov in 1997. Several others exist. Please, let's move to the next slide. Vector supercomputer used in scientific research, that's NEC-SS5. Param 10,000, India developed supercomputer for advanced simulations. So these are several of AI generated or AI powered, computers these days. Intel Core i7 PCs. So today now you see different people carry different computers or laptops in their hands, but the core is different. So Core i7 is more powerful, and the speed and all that in comparison to lower core, and then Crazy XC40, ASCII Red, Google DeepMind, Blue Gene. So these are just examples. You can get more examples on your own, but they are largely AI-powered systems that are capable of doing the unimaginable within a very short time, which ordinarily humans may not be able to handle efficiently. Okay. Now, a short break before we move to the second aspect of our lecture today, which focuses on basic concepts of computing and different programs in computer science. Let me see if I have the code so that we can take attendance at this point. I'll read out the code once I get it, and then you would use the code Please, are you with me? Okay, please, do you have the code with you? Sorry, please, we need to get this code for you. Attendance code, please. Okay, maybe we will continue until okay, you would see submit attendance. So let me see if you can do that. Yeah. So quickly complete that. Ours is AMS 103. So I don't know how AMS 101 got here. Okay. Please do that quickly. Telepresence live lectures attendance form. Submit the attendance using the 3 codes displayed during the live lecture. I think the code is still required. Oh, yeah. The code is required, but let me know if you can see it. So if you can see it, I mean the Google form asking you to present, to log in and then submit attendance, please put yes in the chat box. So we will still get the code for you, please. No, there's no code yet, but do you see on your device a prompt? Does your No, you can't. Okay, yes, ma. It's asking for code. Yes, it will ask for code. Hold on, guys. I don't have the code yet, so we can continue. And then maybe at another point, we can get the code and share with you. I don't know why it's also not showing here on my device. Please let me check again. Okay, so in the interest of time, please, let's move forward. Yeah, there's a prompt, yes. So I expect you to see the prompt, but you don't have the code, so we cannot do that. Basic concepts of computing and different programs in computer science. So here now we are getting to the nitty-gritty of today's lecture. The computing and different programs in computer science, not management science. Okay, so the introductory aspect of this gives us the background about what and how and the component of what we mean by computing. So it's the study of how computers work. So you may not necessarily need the in-depth knowledge of how computers work because you are not a scientist. I mean, you are not a computer scientist. So how they are designed and then how they are, used to solve problems. So, but today the important thing is that wherever field we find ourselves, specialization we find ourselves even after graduation, even any problem you are solving now, you are doing assignment, you are making calculation, you are doing some writings and all that. You can see even research. So you can see that computers play a very central role. So in all sectors. So as defined by the Association for Computing Machinery, ACM, computing refers to any goal-oriented activity that involves computers. So including the designing of hardware, developing software, processing of data, and managing information system. So I told you we are not going to the core of this, but you need to know what computing entails. The next slide, please. Hello, ma. I'm waiting for it on my side. Okay, it has come up here. So what do we mean by computer? I know many of you are familiar with this general definition of a computer as an electronic device that accepts data, when it accepts. It doesn't just accept and swallow like amala. Somebody will eat amala and then you don't. Of course, the amala is also doing some working. I mean, they don't has benefited you. So it is there and then it has been processed. So just like human system, we take in amala and then process it and then take all the vital nutrients from there and distribute to all the parts of the body. And at the end of the day, you see a very beautiful looking, you see a growing lady, you see a growing baby, you see a healthy child or healthy lady or lecturer and all that because you are what you eat. Okay. So it takes in data, okay, as input and process it is according to the set of instructions that is given to it. So the program will be written, the algorithm will be written, a set of instructions will be written, and then whatever you ask the computer, if you ask the computer to add or to multiply or to concatenate or do anything, it will do it for you and produce meaningful information. So the information now that it generates is what we call the output. So generally you have input, process, output. Okay. So and of course, in addition to that, the computer aside the other peripheral devices that are also associated with it that can help you to store data, itself has a large memory to store huge amount of data and as well as perform tasks with high level of speed, accuracy that you can trust. Okay, the next slide. Uh, Maybe you are seeing it on your side. I'm not seeing it here. Okay, so here are the characteristics. So I think you are familiar with this already. The speed, the accuracy, the storage, the automation, the versatility. Okay, so I'm trying to confirm if I have the code for you. Okay, I don't know. We are having a little challenge. I did not receive the code, so it's difficult for me to share with you. So, okay, so please let me handle that, ma'am. My colleague will assist us and then help us out with the code. Okay, so what are the components? Oh, but before we get here, can we see the initial slide? There is a slide before this. Hello? Okay, thank you. So here now, we are trying to still get it because it's part of the deals that those of you that attend this class should be able to register. So I don't know where the code is. Okay, let me do something. Let me shut down the device here and see whether it will to be delivered. I wouldn't know what is actually going on. Sorry, please bear with me. It's because of you. I don't want you to miss the. I mean, you have been here with me. Okay. So please, the next slide, ma'am. Yeah. So we're in characteristics. Let's move to the next one. That will be slide 26. Yeah, the component of the computer system. I don't have it here, but maybe you are already seeing it on your side. Okay, so you are seeing it on your side, so you can see the components of the computer system is basically made of two major components, which we call hardware and software. So just like the name connotes, hard, of course, when you say hard and soft, so ordinarily, I mean literally now, you can say something is hard, maybe like wood or like stone, and then the other one is soft, maybe like bread. So it is not that kind of comparison. Okay, so the software is not necessarily what you can see or touch with your hand, and then you can say, "Oh, it's soft." No, it's not like that. But all the physical components of the computer that, of course, you can touch with your hands are what we describe as hardware. So the physical parts, yes, and then it can be input devices. Like now, I have a mouse here. You have the joystick and different others. You have the keyboard, the scanner, to feed in the data into the system. So they are all hard. And then output devices too, like the monitor. As I'm standing now, I'm standing before this large monitor, and then from there you can see transmission. You can see me standing, and then you are also there at the other side. Okay, so it's an input device that captures through the video here, and then showing you the image, and then projector is also doing its own work, and then we can printer sometimes to bring out the results being generated, that is the output generated by computer. So it's part of what we describe as, because they work together. So a printer is also part of the hardware and the output devices that we talk about. Storage devices like the hard drive, the SSD, the flash drive carry about. So they are part of this. And then the processing unit are also there, the memory, the RAM. When you open your system, you see it there. And then, so please, the next slide. Okay. So the second component is the software. So with the software, just like I mentioned, these are the instructions that make the computer work. Okay, so they refer to the programs that instruct the computer what to do. So we have the system software, we have application software, we have utility software. So for system software, if it is not there, like Windows, it's not your computer is not going to work, it's not going to serve you. So you have macOS, you have like 9 you have application software that you also use. Maybe you want to do some processing or word processing and all that. So Microsoft Office has to be there on your computer or on your laptop. Please, I'm not seeing the slide again. That's just the one before this. Okay, it's not going back. So with that, so you can have the application software, like we mentioned. So if you want to do some drawing, and then you can select which one is suitable for you, and then you work on it. Then you have the utilities that also work alongside, on your system. You want to shut down, you want to edit, you want to all these, they are already embedded, in the then you have the antivirus software that also help you to maintain the sanity of your system. Then data and information, of course, I've tried to differentiate between data and information, and I'm sure you know what this means. So what is data? Data can say is the input, then the information is the output. So when you feed in data into the system, that serves as the raw material that the computer works on. They are unprocessed facts such as numbers, words, images, and then you want to put everything together to come up with a very beautiful or very useful output. And then information is processed, and meaningful data for decision making is available. The managers, for the lecturers, even for you as students and all that. So maybe discuss now after this class. Now, I'm trying to get the code for you. Then I say, let me get you the code. So once I give you the code, and then you put in your details, that is the data. And immediately I can harvest the output from my side. So I can know how many people are actually connected with me at this point, and then able to learn. Okay, so that's a practical example of data and information processing. Okay, please the next slide. So sorry, it's on my side taking time to reflect. So we need to be on the same page. Here now we have types of computers, supercomputers, extremely powerful machines that are used for scientific research. So you can see researchers can imagine or any solution or embark on any form of activities that will add value or that will solve problems. And at that time, they have all these facilities, these tools working for them, which ordinarily someone who is only processing information in the office, maybe a typist or a secretary, may not really require all that. Then the mainframe computers are used by banks, by government, by airlines. So you have them in different sizes, different capacity, based on the results, your objective, what actually you want to achieve. So the mini computers are systems that are used by media organizations, while microcomputers such as laptops, desktop, tablets, is available everywhere. Many of you have it. Embedded systems, computers inside appliances like your cars, the medical devices. So these are different types of computers, and I've mentioned that the other time. So we can move to the next slide, please. Okay, so gradually we are getting to solving the problem of attendance. And so once I have the code, then I'll share with you. Okay, the next slide. Okay, application of okay, so classification of computers by purpose. Okay, me, I don't have it. So you have it. Thank you for that. So we have the general purpose computers. This one can handle different, and also I have it now, sir. So we have the general purpose, and then we have the special purpose. So the special purpose cannot be used just by anybody. If you could go and buy an ATM machine and you put it in your house, what do you need it for? So, there are routers, and then you actually don't have clients that, or you don't have any online transactions you are doing, and then you just go and buy it and all that. But in your case, of course, I know many of you even use more data than the organizations, because you can stay online 24 hours. Is now the engine of today, is the water of today, is the petrol in the vehicle of today. I mean, in your own devices, and so it is globally. Now we move to another important aspect, which is computer networks and the internet. now we are in your domain. Of course, you may not really have all the details, but then I'm sure you know networks, internet. So the internet is the largest global network. As I sit here now or stand here, I don't know where you are, but I want to believe you are within the university environment, whether in your own one classroom or with a friend or by the roadside or in the department or faculty or in the library, and then you just put the earpiece just to prevent distracting others. So you call somebody else if it's not LAN, if it is one, and then you could be in Europe and then we are having a conference here, of course, and then we transmit live. You watch balls, games live, you attend church services live, and then, like we are doing, of course, we do all this. Some of you in Faculty of Administration that we had our faculty week about 2 weeks ago, you could see that some of our facilitators, the mentors, they are outside of African continent. So colleagues from US, from UK, they connected with us and then shared their experience with us, and they answered our questions, made their presentations. We had nice time together. And then the person sitting in the next room also enjoyed the same thing. So this is the power of computer networks and internet. So a computer network is a group of interconnected computers that share resources, okay? We have the local area network like LAN, then you have the one wide area network which covers a wider areas, and then then you have the bigger ones which is the MAN, and then that one covers the whole of a city or a big place like a metropolitan area network and other. So now please we pause here to take the first attendance. I want to dictate the code to you. Attention, please. Are you with me? Now I have the code. I have the code. I want to see your reaction before I drop the code with you. Your reaction, please. Okay, someone says yes. Oh, thank you. So I know we are together. So the code now, capital letter EYG 2V. 2 is letter. Sorry, it's a figure. So all the letters I have called now, they are uppercase, that's capital letters. So EYG 2, then V. EYG 2V. Somebody say it's not clear, I will come again. EYG 2V. So please log in. You have the prompt that you should register your attendance. So please just click on it, right on your device, see the prompt there. Okay, some are doing it already. Thank you. That's good. Fill the form. I've given you the code. Supply the code and then submit. I give you 1 minute to do that. Once again, EYG. Yeah, somebody wrote it, but you wrote in small letters. EYG 2V. Ifeoluwa Abameke. Don't worry, you have seen AMS 101 instead of 103. Click on 101. It's a we will correct that subsequently. So AMS is your course. Please click on AMS 101 and then yeah, I think that solves it. So that's the first code. Please just drop on the first code and then submit. It's going to take it from you. So thumb up once you are done. Just thumb up. Waiting for you half a minute. Oh, sorry, network. Oh, don't worry. You only need a code at a time. So somebody risk rows. You are asking for 3 codes. You need only 1 at a time. So drop that for code 1 where you see code 1, so you'll be able to submit. Peter Godwin, I think you have submitted. Somebody says the site is not responding. We aren't able to submit. It's asking for the second and third code. Okay. Okay, so I will tell you when to submit. Don't worry, I understand your challenge. I can understand your challenge. Somebody is saying the 3 code, yes. Just put the one I've given you. Adeniyi Kwoyi. Yes, he has written it correctly, EYG2V. Okay. Don't worry. What I will put in the first code. When it's time for the second code, I will tell you. Just follow the instruction. You can see now, you are creating question for yourselves. When I've given you my own question, I say, just trust me. So, or you don't want to trust me, you trust the device. Okay, I think there is a conflict now between trusting who to trust. You trust your lecturer, you trust your device. Which one? Okay. You bring a matric number, you shouldn't bring matric number. There's attendance code. Use your JAMB registration number. Since you don't have a matric number yet, AMS 101. Somebody is still talking about 103. If you don't see, you can't see 103 there, you see 101. You see AMS, pick it. We will correct that subsequently. Please, who is this Rick Rose? I think you need to step out of my class. Because you keep dropping the same message that is asking for 3 when I've instructed you. So please, you cooperate. Please don't distract others. I can hear now. Aha. So thank you. Ife Oluwabameke done. Okay, please do that quickly. It's okay. Okay, so please, operating systems, yeah. What does operating system do? It manages the hardware, it manages the memory, or the processes that take place in the computer, and then the applications, just like I mentioned to you earlier. So if you have the window on your system, what does it do for you? So all you can see, you see the interface, and then you write, and then you can begin to now say, oh yeah, change the font for me, and then multiply you like copy and paste and all that. The operating system is helping you with all that. Okay, you imagine, then it's behind. So it's carrying out, so the instruction is being implemented if it is correct, because it is garbage in. The next slide, please. Garbage out. Same thing with the Android you carry in your hand. You see, the operating system there makes it to function. So click on any application, whatever you request for, if it is in line with the program there, it does it for you. Okay. Computer programming is the process of writing instructions that the computer follows to perform tasks. Now, these are not automatic. Somebody has to write, somebody has to think, somebody has to innovate. And so there is an objective, there is a problem we want to solve. How do we go about it? Then we put heads together or heads together, and then we feel, let's try approaching it from this dimension. Okay, do you think that will work? Okay, let's try it. And then we write the code, and then we write the algorithm, then we drop it. Does it give us what we want? If it does not, okay, we can make some improvement. It share some light on, oh, we are not yet there. I mean, so you see the instructions you give it, just like you too, you carry your vehicle and then you are driving. So you can tell your vehicle to pause, you can tell it to move, you can tell it to park. You understand? You can lock it, you can open it. So whatever instruction as you give to the system, via the we call it computer programming, it does it. It can ask it to build, it can ask it to construct, it can ask it to calculate, it can ask it to draw, it can, generate this, and it does for you. Okay. Of course, you also have the AI now that is working in a very powerful way, that even without having to write the programs, it picks from your natural language and immediately it converts that, to its own machine readable, and then quickly processing that. So the high-level languages, we have the Python, the Java, JavaScript, and other. Low-level languages, so you have the assembly, machine code, like I told you, in binaries of zeros and ones. Okay. Following that, the next slide is coming up. You must have seen it. Bear with me. I think we are, yeah. So we have different disciplines. Now we are coming to these. By now, I'm sure you are no longer seeing yourself in the administration, faculty of administration. We have been able to move you farther away from the faculty. Now you can see yourself in computer science. Don't wonder, don't worry, just listen. I will show you, point to you what is going on here, and then you can now appreciate. I'm sure you will enjoy it. Okay, so different programs in computer science. Computer science is a broad field with several specialized programs. So in the university, please, you can go to the next slide. In the universities, you see people specializing in different aspects. So you don't have an island of knowledge, just among humans. So you have to specialize, because you can do something better than another, or you can learn something and make it, to add value to yourself, to the community, or to the larger, to the world. By you putting your own ingenuity and also bringing out a unique innovation that will make life better for us. So computer science focuses on the theory and design of computing systems. So it includes algorithms, data structures, software design, artificial intelligence, computer architecture. You see so many people today now coming into the faculty of computing or computer engineering, or software engineering, or informatics, or geoinformatics, and all that. So the core areas here include algorithms and complexity, programming languages, operating systems, data structure, I mentioned that, machine learning, networks and security, and then several others that you still come across. So that is in the field of computer. Please move to the next slide, computer science. So on the next slide, we are looking at software engineering. So maybe your friend is there, maybe even on OAU campus for software engineering. So come and see some of what they do here. They apply engineering principles to software development. So they are software developers. The software engineers are software developers. So everything about software development life cycle, design and modeling, testing and debugging. By the way, what do we mean by testing and debugging? When you've written a software, does it achieve what is intended to achieve? So you put it to test, run it. And then when you run it, you can see the code. Oh, at a time, maybe you are reading 100 instructions. And then instruction number 1, we are not here yet. Please, you can move back. So instruction number 1 is it's okay, it works perfectly, 2, 3, 4, 5, 6, and you begin to see the output, and then it gets to maybe number 15, then it hangs and it's telling you, showing you some funny blinks, and then you are looking at it, okay, what's going on? It's no longer implemented because there is an error somewhere. So it's locating and correcting error. So that's what debugging is all about. Project management, please, the next slide. So for software engineers, they help to manage projects of diverse sorts of different kinds and magnitudes, because they can help, to write or design the software that will manage different projects. Okay. Information technology is another aspect. So when you hear somebody is studying IT and you're looking at it, what is even studying? He's studying IT. What is IT? Information technology. I knew that in primary school. I did it in secondary school. So what is it? They are now studying that we have not studied that is different. I want to spend 4 years, 5 years in the university studying information tech. Look at it now. You can see it's very much more than you could imagine. It focuses on the use of computers to store, to retrieve, and transmit information. So the basic thing you knew was that. But under here now, you have different specialization like network administration. Okay, now we are here in in this class. How come that we are able to connect? So that is IT. Okay, IT infrastructure management, databases. Without a reliable database, organizations will not function. So some of the problems we are having in Nigeria is lack of database in Nigeria. So that's why for you, you may not really appreciate it now because you have not encountered serious life challenge or having some demands that will be time bound, and then you quickly have to provide some information and retrieve information. So in many organizations you go to in Nigeria, you keep providing or supplying same information 2, 3, 4, 5 times. Okay, what happened? Last year you were here, this information was collected, the data was provided by you, and it's not here, they're asking you again. But when we have good data, you see, the information is synchronized. And then if you are a visitor or you are a tourist and you came to Nigeria, anywhere you get to, the number of days you have left in Nigeria is already known by whosoever. If you want to buy something in any supermarket here, and then once they put your passport and then they scan it, immediately they can know that, oh, okay, so yeah, this. So database. Also for taking decisions, making decisions, and then moving forward, we need database. Cybersecurity is related to information technology. You can see today's biggest challenge, I can tell you, is cybersecurity when it comes to computing, engineering, and all the related fields. Cybersecurity is a world on its own where you see the bad boys, you see they are there sitting down like you see the thieves, eh? How they go and lock themselves in a very secret place where nobody will be able to identify them or find them. So the same way, so you have in the cyber world or you have in the IT world, the technology world, you see the challenge of theft. And one major constituent of this theft is the cybersecurity, which goes beyond just stealing information, but attacking and destroying. And just like some of you who are Christians, the Bible says that the thief cometh not but for to kill, to steal, and to do what? To destroy. So that's what uh, the cyber criminals do. So it's a field that is much more related to us in management sciences, because we work in various organizations and rely on information, store information, distribute information, take decisions based on information generated, government decisions, private organizations, public organizations, individuals, institutions, like that. So cloud computing is another aspect related to information. You can see it's a very wide field. So for cloud computing, of course, You don't have to store all your information on the physical room or the physical gadget in your room, because it can be stolen, it can be damaged. But right in the cloud, you can operate from there. You have your office there, you have a lot of warehouses outside that you cannot even know. You see the problem Nigerian government is facing when it comes to tax in the tax world. You find most of the multinational, many of the multinationals generating income in Nigeria, and then they take it to the tax haven because they are advanced in technology, and then they do all this trading without being tracked fully, even though they have their own record. But once they know that we don't have the devices and they are not able to track them, and then they take the payment of tax to tax haven, and so Nigeria loses so much, and then they generate much no profit from here. All these has to do with IT complexities, cloud computing, and what have you. So we need to be well grounded in this. You as a management science student, you need to be well grounded in it, and then for you, you need to get prepared to support technology infrastructure. Even though you may not be the expert in the IT related field, but now with this exposure you have, you can see the demand. You know, like even with you in the organization, you have the IT expert that you network together, and again, we work together to achieve the overall organizational objective. Information systems. Information systems combine business and computing knowledge. You can see here now. So we learn to use technology to solve organizational problems. So that's why we are here. That's why we are here. So you can begin to look into any of these lists, these topics: business analysis, systems design, enterprise systems, database management, decision support systems, e-commerce systems. So we are encouraging you, okay? Oh, somebody said my phone is ringing. Thank you. I tried to put it to, sorry. I think the distractor has also left. Thank you. So, cybersecurity now, of course, I told you, is very, very relevant. We cannot fold hands. It's one of the troubles that management, you know, business executives are running a task because the Yahoo boys, somebody put Yahoo boys, thank you. The bad boys, they must not get into the into the site. So once they're able to break in, then trouble ensue. Stealing information, and then just like a thief, we find every means to break through. They come in the night, they study the environment, so they also study over time. So that's why you are not careless opening the sensitive devices to strangers to use, or giving access to everyone, or people just come, use your devices. No, you don't permit them. That's why you use very strong password. So the password that that cannot be guessed by just anyone. Okay, these are part of. Then you also do these two steps verification. So with the two-step verification, it's just to edge against the activities of these cyber criminals. So cyber security focuses on protecting computer systems and data from attacks. The attackers are everywhere. By the time we get to the practical aspect, I'm going to share some sites with you where we can monitor in real time the thousands of different cyber attacks that are happening currently in different countries, in different, continents. So you can see within Africa, what is it in Nigeria, how is it in Ghana, even as we speak. So in per second, you see it in thousands, attacks of different sorts. Okay, so we have the website for that, where you can freely see the outlook and where we stand, and which sectors of the economy is being targeted by these attackers. So all this you can see. That's what the specialists in cybersecurity bother themselves with. So Network security, they want to secure our network, because if this network is weak or they're able to break into the network, that there is problem. Look at OAU, okay? OAU, yeah, the network security officers, they do that, just like you see the security men going about, guarding the banks. So the same way you see them, it's not only you just cited you as an example. So because the assets here today now is not just a physical asset, like you find the physical olode, or you call them a vigilante, or what, securing. Now you now have people who have to secure this huge investment, which is owned by different organizations. So every organization has this, this security challenge that they have to pay attention. They don't have to wait until it happens before they hedge against it. So network security, cryptography, okay, that is part of securing, the network. Penetration test. So with penetration testing, they want to see how strong, how formidable the network security of OAU is. So they come in as a white hat, hackers, and then they carry out some penetration tests, and then they want to see whether it is formidable, or that there are some security challenges. So it will be able to generate report in real time. Okay, I've done that before. And then immediately you can now see, oh, we are exposed. So it will show you the level of exposure. For every organization that we work for, or you will likely work for, this challenge is there. And then you can, with your knowledge, help the organization, to hedge against cyber attacks. Ethical hacking, of course, is another area that is under cybersecurity, that yes, you can go into it, and I encourage you to do it. Yeah, and then you have certificate in it, and then ethically you can hack. Okay. But you don't hack without permission. So you have the permission of the organization. You are helping to see how strong, how prepared, how ready, how formidable the system is against unexpected attacks. Okay. I think, yeah. So no more disturbance. DND. Thank you. So that's one of it. Digital forensics. Okay. Now, this is another area. Like we have in accounting, we have forensic accounting that takes us into deeper aspect of probing, and also prosecuting the attackers, and then taking them to the court and all that. So you have digital forensics. Risk management, okay? Every organization is also prone to risks. So then there are managers who are there to help to improve on the existing system. Thank you. Okay. So please, the next slide. Computer engineering. Maybe some of you, when you were in secondary school, you wished you were a computer engineer, but then when you were in physics class, you struggled, chemistry, you struggled, mathematics, you struggled. Then you say, I don't want to kill myself. Let me run away from these fixes. Some of you will go and hide. When the lecturer or your teacher comes in, then you run away. Okay? So now, the people in computer engineering, what are they doing? Theirs is the combination of electrical engineering and computer science. Why and for what? They are set to design hardware and embedded systems. So we need them. They are real. They work now. I told you that the physical walls that existed in those many years, that people in air sciences have no relationship with the people in physical science. Or that's in arts, or in accounting, in psychology, because they say natural sciences or health sciences or engineering. Today the story has changed. So now a health worker needs a computer engineer who will help them to develop the app that will be embedded in the system, the wearables that the clients would need, maybe like the example I mentioned the other time, to monitor their BP. The doctors don't have the skills for that. Yeah, they don't have the skills for that, but they know what they want. So they share their the objectives then with the engineer, and then the engineer tries to understand, then sits down and puts the codes together or the instructions together, the algorithm, or write the program, and then runs it, and then it generates the expected result, and then here they go. So computer engineering, there you have the digital logic, microprocessors, embedded systems, Internet of Things, and then the robotics, which today is a big challenge to many individuals who will not improve themselves. Like a question that I usually ask from my master's of business administration students, I tell them, and I ask them, do you think that computer or artificial intelligence will replace managers? And some will say, no, it will not replace me. You must tell me the reasons why you feel it will not replace. And some say, it will replace them. Okay, let me know the reason. And then they enter into debate. And so people now give different reasons why they feel the computers or the artificial intelligence will replace uh, the managers. But in the real sense of it, it is not supposed to be. But it's a big challenge. It will replace others who are not making any value addition to themselves. So I challenge you, please don't stay at this point. Add value to yourselves and then ensure that you are up there, and then you're relevant. They call you, you consult, and you earn your good money, and then you advance about. But artificial intelligence is another area which you are well familiar with, but what is actually embedded or inherent in it, it involves the creation of intelligent machines that can learn. Like you are here learning, it learns using raw data that is provided to it. Okay. Like now we are taking these lectures, and then we are taking attendance. So I can generate different attendance over time. For the whole of this period, I give it to AI to now let me know the serious students and give me the pattern of attendance. Then it will tell me these are our serious students, then these are the set of serious students. So that when we eventually write exam, we even know people who ordinarily we expect that no, they will do very well because they are serious students. All of you are serious, I want to believe. Okay. So the focus here covers machine learning. The machine learns, it reasons, we've talked much about that, makes decisions, advise. Then the natural language processing, we've talked about that, robotics, yes, more of that. Expert systems, more of that. Within the next few minutes, maybe 1 or 2 minutes, I share the second code with you. Please, can you put the code now? Code 2. We are passing, then they are taking attendance. 8E 3ZD. E, capital letter E, 3Z, capital letter Z, then D, capital letter D. I think somebody is writing that. 8, yes, E, yes, correct, but all should be in uppercase, capital. It is not he. The last letter there, please can you delete? Opeyemi Amusan is not correct. Iremide 2642, that's correct. Iremide has written it correctly. BE3ZD. That's correct. Opeyemi Amuson, can you please retract that so that you don't confuse others? Yeah. Malik Olumide, that's correct. Thank you. Enoch Ayodele, correct. Ifeoluwa Bameke, wrong. Ifeoluwa, what you have written is wrong. Please retract it and don't post anything further. Oluwuyi Ayomide, you are wrong. Please retract it. 8E, 3Z, letter D for dog, D for donkey. Ifeoluwa Bameke, can you please retract what you have written? Omotolani, please, can you retract what you have just put now? Please don't confuse people. Ifeoluwa Bameke, I think you are here. It is not a robot that has dropped that link. Can you please delete it? The last letter is D. 8E, 3Z, D. D for dog, D for donkey. Okay. Yeah, so you can put the second code like that. Now we move forward. Other computing programs that we have are health informatics. So you can see the reason for that now, because now is a world of multi and interdisciplinary. There is no big I, small u, or technical high and the less technical u. Everyone has to work together. Bioinformatics, cloud computing, game development, computer graphics, and animation. All these are going on. Yes, but the ones that are much more relevant to our field, I think discussed. But if you are interested, of course, cloud computing is very much more related to us and all that. So what is the importance of computing disciplines? Number one, career opportunities, information tech. We've shared it together. Software development, cybersecurity, data science. So you see, all these set of specialists making a lot of contributions to our community. Okay, improvements in productivity. So with computers, which of use of computer and a lot of professions in computer, you see our ability to produce or generate much more or better results has been realizable all over the years. Okay, so you can do more within a very little time with your system. Driving innovation in all sectors of the economy, I agree with that. If you, for aviation, you see them, don't have to even travel anywhere. You can book your ticket and then you can even log in, you can check in, right from your home. You can select your seat, you can make your payment. You want to sit in the aeroplane by the window side, you can do all that right without getting to the airport. So you only watch for time. Okay, you only wait for your time, your check-in time, so that you don't miss your flight, and then you go there. Okay. Support national development through digital transformation. A lot of countries that are up there today that with so many countries dread. What is the secret of their power? It is technology. Okay, why is Nigeria still struggling, to to overcome some of the BEPS? That's a basic that's erosion of profit. Okay, it's because of our low level of development in terms of technology. Even in many of our organizations, they don't send staff for training because they don't want to spend their money. So that's why you even see education sector is suffering in one way or the other, because there is not much of this investment into you. Sometimes you struggle on your own, and then the government supports you. So, but whichever way, you still have to be at your best. because with education, and then we can achieve this transformation with the use of digital tools that are available in different fields. Computing remains one of the fastest growing professional fields across the globe, and it's influencing all fields. Okay, if you are a nurse, it influences you. A driver, it influences you. Anything, it influences you. Okay, now we pause again to give you the last code. Are you with me? Once I give you the last code, just listen and be all here, please. If I give it to you, then you submit. The moment you put it, you submit. If you waste time, you are on your own. Get set. Capital letter B, capital letter X, that's X as in xylophone. 2, that's figure 2. Capital letter W for window. Then the last one is capital letter P for purple. B for ball. X for xylophone. Figure 2. W for window. P for purple. BX 2 WP. Correct. Submit quickly. Don't waste time. If you waste time, you will be locked out, or you will not be able to, and then the system is also monitoring you. If you share the thing with someone else, you are on your own. I told you, you create more problem for people who did not participate when, so it's a form of faithfulness, which we call tax too on the system. So don't engage in that. Okay. Please quickly do that. Thank you. You are present. I can see you are done. Everyone is done. Thank you. So we move forward. Again, importance of computing to management sciences. So we've looked at it from the general perspective. Now we bring it back home. We have come to computing science today. We've explored, we've checked different fields that are available here, the specializations, what they offer, and then we have learned so much about what they do, how it benefits the world. Now, what is the take home for us as management scientists? Okay. The modern organizations depend so much on computers for what? For decision making. Because as an accountant, the raw figures you put in is not needed. Individual customers' figures is not needed. You can't report that in the financial statement. You take everything together, and with a large number of clients or customers generated over a period of 12 months in the organization, that's January 1st till December 31st of every year, which is the accounting year. For accounting students to understand this, and for those of you that offer ACC 101, Introduction to Accounting, you understand this. So you don't need the individual items to be reported. What you need is the processed information. We call it financial statements. And then the auditors come to audit that. And they confirm everything they need to do and vouch, and then carry out the test. And then they will put their signature to tell the world that this financial statement shows a true and a fair view. How many of you working, or your daddy working in organization, your sisters working, and then they now sit down to start calculating with calculator? No, they don't do that. So for us, we are benefiting so much with these available tools in computing science, right in our field, to make decisions, to know, okay, in the real time, you can see how the capital market is performing, to see which company is doing well, which one is not doing well, which business line is doing well, which one is not. And then, do you want to sell your shares? Do you want to buy shares? Do you want to acquire more, or you want to hold on? I mean, all these decisions, you can take it based on what is going on. okay, in the mind. Then how do you get to know this? Is because in the real time, the computers can help you to generate reports and then guide you. The communication is made easy, financial reporting made easy, database management made easy, human resource planning made easy. I remember the last time the university here uh, did staff test. That's they do recruitment test rather, and then they carried out the employment process. Most of these processes happened online. Okay, so human resource, marketing analytics, operations management, and what have you. Can we move to the next slide? So you can see it's easy for us to use computer to apply it to solve the real world problems for managers, for other tasks that are repetitive in nature. It's very easy, particularly for those of us in the management science, to have improved organizational performance. Importance of computing to management sciences still continued. So now today, payroll services is easy, inventory control. The next slide, budgeting, data analysis, customer relationship management, all these, they are here with us and then we enjoy. Please submit to attendance. Somebody was asking whether to submit. If you have not submitted by now, you are on your own. Thank you. Please, the next slide. So you are able to handle your tasks with ease, and then you can do more, with within less time. Uh, in terms of the characteristics of a computer that we shared together, speed, accuracy, storage, automation, reliability, all these we enjoy as a management scientists. Please, the next slide. Okay, we talk about using some of the facilities again, to achieve our specific goals. And then, please let me have the next slide. Okay, yeah, the hardware. So we talked about the hardware, we talked about the software. So for us printers, we use that for reports. Please, the next slide. The barcode scanners are there. Today now, instead of auditors doing the physical stock audit, you can see, right, even when you are selling, if you go to selling point, right in the supermarket, the items that have been picked by different customers will just be scanned and then the amount is determined. Then we use data, for all these, for, processes and the services that we enjoy. They didn't just come from the cloud, they came from our computing science. Software, yes, for us as administrators, the system software we use majorly, we use Windows and then Linux and all that. And many of the application software, of course, Word, Excel. Many of you have learned Excel. You use PowerPoint, like this presentation I'm making now is in PowerPoint. Okay, Sage, that's a specialized accounting software. For data analysis, we have a lot of specialized software, human resource systems. You have many of them for marketing systems. Can you please go to the next one? For Google Analytics, database tools like SQL. Some of you are learning all this. Thank you. Yeah, so then Access is also there and several other ones. So you can pick and choose. You can pick the one that you feel is relevant or much more you are comfortable with. And then about computer networks and management of the internet. Today now we have made use of, we ride on the winds of the internet to communicate you freely, reach out to you. And then we have chatted, we are still chatting here. You can see communication going on, online meetings, you can see us right away here, cloud storage. So you can see the material can be shared, without me physically reaching out to you. Online banking, e-commerce. Please, the next slide, enterprise resource planning systems. All these are made easy. You can see how much we're enjoying. So without even knowing the people that are behind it. So there are these computer scientists. So we must work with them. We must network. We must collaborate. Data science and business analytics, what you have here, the statistics, the computing, the analytical use. I mean, you see data in real time, and then you see some of the graphs that are designed, and then you can see the outlook of how your the business has fared, the patterns, and then you are able to make some market analysis and some sales forecast. You can segment your customers. I mean, you see a lot of real patterns that can guide the managers in making the right information that will move the company forward. So please, the two other slides, please let me have them before we close. So yes, we have from cybersecurity now. You understand that why we must prevent. Please, the next one. I've told you how to go about it. Why you must get involved. Okay. Please, the next one. So, which is the last, but not the least. Yes, cybersecurity. Yes. So, please, I think it's a repetition. Please, can we go to the next one, please? The very last one, please. Yeah. Thank you. Okay, so I think we've come a long way today. Please let me have the last slide where we have the recap. Yeah, so we've come a long way. We talked about the computer evolution, the historical perspective from evolution to evolution to the fifth generation of computer, the hardware. This hardware, software, we are still going into more details of it. Okay, the networks, this is just an introductory aspect of it. Major programs within computer sciences, we have introduced you to this, but how do we come in? How do we practicalize some of these things? So we still get into practical session. Today, I want to believe you have actually not wasted your time getting this first contact session. You've enjoyed it. I have enjoyed delivering the message, the lecture to you. And I want to believe that one way or the other you'll be impacted. Please keep the knowledge flowing and updating yourselves. We'll still release some materials to you to read, to follow up, and get prepared well ahead of time. So for subsequent contact sessions, we'll be sharing the materials ahead of time, and then you can have access to it. The link for joining our sessions remains the same. So please ensure that you are available for the lecture. The semester is running fast. You are already a student, even though you are waiting your matriculation. Don't relax, don't travel home, don't sleep off back in the hostel. Get connected. If you have any challenge, get in touch with your departmental HOD or friends, and don't suffer in silence. Don't self-manage. We are here to assist you. I wish you all the best. Thank you. I bring you greetings from my colleagues, Dr. Adeton and Mr. Debisi in absentia. Thanks to the technical crew and the assistance we are getting from the Cybersecurity Center teleconferencing room. Thank you so much, sir. Thank you all. Enjoy the rest of the week or your weekend. Thank you. Bye.